Hello, my name is Paul Fanning. I'm the editor of Eureka magazine, and I'd like to welcome you to today's Design Online webinar in association with Igus, entitled Low-Cost Automation and Robotics. This will be presented by Igus's Low-Cost Automation Product Manager, Adam Sanjurgo. But before I hand over to Adam, I'd just like to remind you that you can ask questions during the presentation by typing them into the box on the right-hand side of your screen. We'll hopefully have time to answer them at the end of the presentation, but should we not, we will be handing these questions on to Igus, and they will hopefully be able to answer them for you offline. And with that, it just remains for me to hand over to Adam. Adam.
Excellent. Thank you, Paul, and thank you for the introduction. And also thank you to Eureka for letting us be involved with this webinar, and thank you to those who are in attendance. With this presentation, we hope to give a very small insight into the world of sort of low-cost automation and Aegis, in the hope that the information that we can pass on is of use to you. Hopefully now, but maybe not if it's not useful now in the future. So. This is our sort of very brief agenda, and please don't worry. I know when agendas are normally given on webinars that they mean it's really long. This is not a long webinar. This is a short webinar. But so yeah, very quickly, in case you weren't aware of Aegis or don't know of Aegis, I'm going to just give a very brief introduction to the company and then some of the products that we also manufacture. What is LCA? And I'll say LCA a couple of times through this presentation. It's essentially low-cost automation. It's just a short form, quicker to say. What automation solutions we actually offer, and what return on investment expectations you can see, and some real-life applications. And then the last section will be on our robot control, our IRC, and Angelos, my colleague, who's also with me here today, he will give us a very nice run through of how you can actually use the software to program a robot very quickly and very easily. So let's carry on. So an introduction into Aegis. As I said, we are Aegis UK. Me and Angelos are from Aegis UK. We are 2 of 120 employees, of which 55 are sales engineers and product managers across the field in the UK and Ireland. We have 12 million parts from stock across 11,000 lines, ready to deliver within 24 hours. We make roughly 200 deliveries per day, and we run 8 to 8 Monday to Friday and 8 to 12 on a Saturday. Some other information, various ISO accreditations, but more sort of interestingly, what happens at Aegis UK, we have a fully automated ready cable line, so we can take any length of cable of any size, and we can terminate that with a connector to a customer's specification, and it's fully electrically tested. We also have an installations team that can take a fully harnessed ready chain, and I'll show you what I mean by that in a second, and essentially take that on site and then fit that to whatever, a machine, a crane, whatever it might be. We also have bearing facilities where we do linear system assembly, lead screws and drives assemblies. And then most importantly for myself and Angelos is what you can see in the middle of the screen, the middle picture, which is essentially our lab for testing, for development, for everything to do with low-cost automation. So that's a little bit about Aegis UK. We are a family-run company from our Aegis Cologne in Germany, basically, which was founded in 1964. There's roughly 4,150 employees worldwide, which are roughly nearly 50-50 split between Aegis Germany and then the rest of the world. Some other facts and data that you can see there, but most interestingly for me is the fact that we have the largest test lab in our industry, which is 2,750 square meters, of which we carry over, or we make over 15,000 tests per year, and that is to give us facts and data and information that we can pass on to customers to give lifetime, sort of estimates on products. So that's the sort of company part. A little bit more about product now, if you don't know what we do. We are essentially a motion plastics company. We take tribologically optimized polymers, and then we create systems from them, and they can be as simple as a sleeved bushing all the way through to a complete linear system, which actually is what a lot of the Aegis low-cost automation is born from. Without the base sort of polymers and materials, we wouldn't have what we have today, which we're going to show you. And the main sort of key advantages of Aegis parts is that they're completely maintenance free, they're completely lubrication free, they need zero maintenance, so they lend themselves very, very well to various different environments, from food and packaging industry, medical industry, even farming, vertical farming. Across the board, there's a huge range of applications in industries that can benefit from using polymer technology over conventional lubricated metal technology. So looking at these products in a little bit more detail. So we have two sides to the Aegis business. One is energy chain, like I mentioned before. So we have basically chain systems and robotic sort of management systems, where if you have cables or hoses or any kind of power that is moving, then that should be managed, essentially. So it has to be managed within a system which will protect it, which will obviously make it last as long as you want it to. So yeah, chain systems. We also have the cables, which I mentioned before, and also ready to install systems, such as the picture you see, which is a ready chain rack, which means you reel the system up to whether it be a machine or whatever, and you can simply plug it in, plug and play. So on the drytech side, which I know a little bit more about, I'm a little bit biased towards that side, being the mechanical side, as I said, so bearings and spherical bearings, linear systems, all the way through to different sort of stock materials in bar, in plate, in sheet, in filament, to 3D print or whatever process machine. We also have lead screws and rollers. There's just such a huge range of product that we have, and this is only a very small snapshot. So if any of these other products are of interest, then please get in touch. We can talk about those offline, or send some questions, and we'll be happy to obviously answer those as well. So okay, so brief introduction done. Over to sort of what is LCA? What are we talking about when we talk about low-cost automation? Well, essentially, it's a family of products that are within the Aegis range, and they all have the same end goal, which is to essentially provide anybody, and I mean literally anybody, whether that is a machine builder or a machine user, to automate tasks that were previously done manually, or that were previously not thought to be sort of cost effective to automate. And whilst doing that, we also want to save time, we want to save cost, we want to improve productivity, we want to reduce downtime, and it has to be easy and it has to be quick. So those main points are the sort of whole philosophy behind what I'm going to show you in a second. And all whilst doing this, automating tasks, we want to upskill the workers that weren't, or that were doing those tasks, so they can go on to do something that's maybe a bit more difficult for a robot to do, or whatever. So what solutions do Aegis offer? What are the main solutions? So there's actually quite a few. There's many that I'm not going to mention today, but when we talk about sort of automation solutions, we talk about three of the main robots or robot sort of systems that we have, of which we have three. So you can see them here on screen now. So we have a Delta robot on your left, we have a gantry system or linear robot in the middle, and then we have our articulated arm on the right. And we have three reasons for having these. One is fast, one is modular, and one is flexible, all having their different advantages for different applications. So I'd like to look into each one of these in a bit more detail, just to give you, a real snapshot as to why we have them and what they're used for. So the fast one, the Delta robot or parallel robot, which it's also known by. So yeah, this is our Delta robot. And we have two sizes of this. When I say two sizes, we have a sort of small and a medium size, one with a 360 millimeter sort of working space, one with a 660 millimeter working space. And, again, this is a very, very simple pick and place robot. It can carry a payload of 5 kilograms and with a minimum, when I say minimum, we say minimum picks per minute of around 60. And the idea behind this robot was to make it completely customizable. So actually, a customer can take this robot as you see it on the left-hand side of your screen, built inside a frame, ready to plug in, or it can come in a flat pack. We also make it customizable in terms of having it with or without motors, or with or without controllers. So it's completely open to what the customer wants to do. If they want to fit their own motors to it, that's fine, not a problem at all. So that's the Delta robot. We then move on to our modular system or linear robot. We have them as room, line, and flat gantry systems, depending on their configuration. And this is, again, showing a couple of different gantry systems on screen. So on the top right, you have the line gantry, and then the bottom left, you have a room gantry, so XY or XYZ. And the reason for these being modular is that actually they can have a working space as small as a phone or as big as a room. You could have a gantry system working in the size of a single garage. They can be really quite large. They can carry payloads of around 25 kilograms, dependent on their configuration. We can do completely application-specific design. So what we take the customer's requirement and we can design it to what the needs are. And they can have 2, 3, or 4 axes. So if you imagine the room gantry on the bottom left, it has a rotation device on the end effector there, or the end Z-axis, making it a 4th axis. So that's why it's our modular version. And some other sort of aspects to the gantries that we can offer is supplying with frames. So a couple of examples of height adjustable frames. We can also supply it with energy chain systems and troughs and towing arms and things, dependent on what the customer's doing, all the way up to sort of really quite complex systems like you can see here, some really large, heavy duty gantry systems with gearboxes and things like that. The articulated arm or robot arm, which is our flexible robot, which is the newest version that we have, is RoboLink DP. So this has a working reach of around 790 millimeters. It can carry a payload of 3 kilograms at that reach, so 3 kilograms at that full extension. And roughly with around half a kilogram, you can achieve a minimum of around 7 picks per minute. So, roughly 1 pick every less than 10 seconds. So, and the reason why this is the flexible robot is because actually it will perform many tasks, because it isn't a set size like a gantry or like a Delta robot. This is an arm working in a 360 degree sort of space. So if, for example, the task that this robot was set out or sort of implemented to do, if that task was no longer required, then this robot is very, very quick and easy to deploy to do something else, to do another task. And just showing one of my favorite applications here that RoboLink can do, which is the dispensing of beverages. So another sort of idea that we like to offer as well is that actually the robot can have, if the customer wants, a different color. So we can have a RAL color, like you can see here on the left, a yellow robot to give a bit of a sort of twist. The customer can have their own corporate branding on the robot if they'd like to. We can also have water transfer. So you can see here on the right-hand side a sticker bomb design. So we can water transfer basically anything onto the robot if a bespoke and special design is required. And something slightly off piste, and I just wanted to share because it's really cool. We're really proud of this. Last year, we were approached by the Gadget Show, who asked us to get involved with their 400th birthday or episode celebrations, and they asked us to do something rather rather obscure with a robot, something that's probably not been done before. We welcome any challenge to do something as quirky as this again, but the idea was to strike a match and to light a candle on top of a 3D printed cupcake, which we were able to do, and Angelos programmed that robot to do it. So you're going to learn from the best very soon on how to program this robot arm. So yeah, just thought I'd share that. It's quite a cool thing. As I say, we're very proud to have been involved. Back to more fairly serious things, but as important, return on investment in terms of what the expectations are. I'm sure everybody in attendance, you don't need me to tell you about the return on investment. It's simple. The higher the investment, the longer the time is before you get that return on investment. And our whole idea with low cost automation is that it's a lean investment. It's a smart investment. It's something that you will get a very, very quick amortization time to get you into that benefit as quick as physically possible. And another sort of thing from Igus that we are now saying is that we have to improve the technology. We have to get costs down. So tech up, cost down, it really is our job. And if we're not doing those two things, then we're not doing our job. So it's very important to us to be achieving this and to helping customers with the technology whilst improving the costs and giving quick return on investment. Okay, on to some real life applications. I'll show you a Delta robot, a gantry, and then a RoboLink arm, and then just a general video. So four videos. They're only fairly short, and yeah, let's go into that. So yeah, this is our Delta first and foremost, and actually this is a robot that has been used within Aegis in Cologne, and this has been used to take what was once a very, very manual and repetitive task of building an energy chain, one of the smaller, fairly sort of high volume chains that we have. And so this Delta robot is picking up the very, very small individual links of this energy chain, feeding it into this machine, which is then building the chain via a clipping device. And you can see the chain here, which is finished. So something that was normally very manual, very repetitive, is now being done lights out. So they can turn the factory off and this will still carry on, and they will still have chains being produced throughout the night. This is more of this is a customer video. This is a company called Mass Portal, who make 3D printers. And this was a gantry system that was commissioned essentially to service a bank of 3D printers to enable, again, for the company to walk away and have printing continue throughout the night. So you can see here the printers being used. When the print is finished, the gantry will come in. It will take the print plate. It will feed that into a rack. It will collect a new print plate and give that to the 3D printer. And so the process continues. So again, kind of industry 4.0, light out factory, all those key things. And then this again is another customer video, which is demonstrating kind of value stream kinematics of having a whole production line using articulated arms. And the reason for the use of the two robots, as you can see here, is that they have a press fit. So that this bushing here is being press fitted into this assembly, and one robot would not be able to do that. But because we have two, they're able to perform the task and complete the job. And obviously they're doing various things as they sort of carry on with this. So this is the RoboLink DP that we showed previously. And yeah, this is also using Igus robot control as well, that we'll show you very, very shortly. And more of a general video, just showing various different applications, from hitting a drum kit symbol to picking up worms. This is a worm factory, to testing, so testing of buttons, or scanning, testing of touchpads, pharmaceutical production, pick and place of various things, dispensing robot, to production lines, so either handing or helping workers with parts to a machine or onto a production line, to dispensing of liquids onto a part. Hopefully they were of interest. So I'll just do a very sort of brief intro into Aegis Robot Control, and then I'll hand over to Angelos, who will go into the sort of demonstration. So this is a new development for Aegis this year. We've had the 3 different styles of robot for some time now, some years, and until this year we didn't have what we have now, which is the Aegis Robot Control, which is a software, hardware package essentially. And the main key point is that actually the software is completely free. So anybody in attendance on this webinar right now can go onto the Aegis website, download this software completely for free. There's no license fee or anything like that, and you can start to play with our robots. You can start to learn how to program a robot. And the main thing for us with this was to make it so you do not have to be a robot programmer to program a robot. And Angelos will demonstrate that in a few minutes. And you know, with this is giving the ability and the opportunity to people that were previously, you know, maybe a bit standoffish of robotics, or they didn't think that it was going to be, you know, easy enough for them to try and implement or deploy a robot into their application. With this software and this hardware, and with the help of myself or Angelos, we can say, yes, that is the robot for your application, and the Aegis Robot Control will do exactly what you need it to. So I'll shut up now. Sorry, I'll take a breath, and I'll hand over to Angelos, who is going to essentially show you the robot control in more detail and how to program using the Aegis Robot Control. Thank you.
Thank you, Adam. My name is Angelos Bitivelias, and I'm working as an automation engineer in Igus, UK. As Adam have mentioned, Igus Robot Control is a hardware and software solution. Hardware comprises of a compact control cabinet, a hand pendant, and an emergency stop, while the software is a Windows-based program provided free of charge to anyone interested in automation applications. Today, we're going to have a quick walk through the software, which is part of the Igus Robot Control. And the software, of course, can be downloaded for free, and it includes the kinematics for all of the Igus standard robots, including Cartesian robots or gantries, Delta robots, and the Robolink articulated arms. We will start by opening the Igus Robot Control software. This is a standard procedure. We will locate the Igus low-cost automation logo and double-click it. This will open the software. We can now see the user interface of the Igus Robot Control software. And on the top, you can see that we have the 3 main menus. It's the file menu, where we select the robot that we want to control. Then we have the scene, where we can basically move and adjust the screen of the digital twin to have the point of view that we require to program the robot in an easier fashion. And then we have the motion tab, where we have different tools to actually connect the hardware, the physical hardware, and reference the robot, which is the standard procedure. Or we can also program the robot offline, so we can just program the digital twin of the robot without having access to the hardware itself. All of the restrictions on the motions are still there, so the program that we're going to accomplish with a digital twin can be loaded directly to the actual robot. On the side, we can see the status window, where we have the main information, if everything is okay and if our robot is connected. And on the bottom, we have various different settings, which we're going to have a look later on. Initially, as I said, all of the kinematics are preloaded in the program, And we can move the robot by using the digital twin or by using the jogging menu on the bottom. And if we actually have the Igus robot control hardware, we can also use the joystick. Most of the robots, they have already preloaded sample program in there. This is to help you understand the kinematics and the motion that the robot can accomplish. And also you can build on this program and modify it to fit your specific application. So when I go to the program execution, I can just press play, and the robot will perform the sample program that it's already loaded in there. While the robot is moving, we can also alter the speed. We can make it slower or faster, and we can, of course, edit the program if we want to. So we've just seen the Robolink perform a motion program. Let's now load another robot, another type of kinematics, and we're going to go to Delta robot. So we just press the Delta robot. Everything is loaded. So you can see that, again, the Delta robot will have a sample program loaded in there. So let's see it in action. And while the robot is moving, we can also use the scene commands to make everything easier for us to see. So we can see now that the Delta robot is simulating a pick and place application on a matrix, which of course it can be programmed by a function inside the Igus robot control. It's as easy as selecting the distances and the items that you want to pick, and the matrix is calculated, so you don't have to program each point separately. Now I will stop the motion, and then we can try loading another type of robot, which is one of the Cartesian robots that we do. So you can see that, again, on the digital twin, moving the robot up and down, it's as easy as selecting the axis that you want to move and moving your mouse. And now we're going to have a look on actually creating a sample program for an application. So initially, we know that all of the pick and place robots will need to have an end effector in the end. So to configure an end effector in Igus robot control, it's very easy. We just go on File, we select Configure Project, and if we go to the Tool menu, we can select some various end effectors from known companies. So in this case, I will select the last one, and I will just press Apply. Now the tool center point, or the actual point where the robot is gripping and picking stuff, has changed. If you see, the orientation has changed. And also with the gantries, we can do, as we said, they're modular, so we can do different customizations. So we can change, for example, the length. Again, this is very easy by going to Configure Robot, selecting the gantry, and for this example, we will increase the length of the y-axis. After I have selected the actual working envelope and I have increased the working envelope of the robot, I press Reload. Of course, save changes. Now we can see that the y-axis has increased, and we're ready to actually go and program our robot. The programming is done by the current program section on the top. So I can just press Edit, and you can see that we have easy point-to-point programming. The first function is, the first line is always the start, which is basically telling the program which robot we're using. And then we can start moving the robot to the place we want. So I will start from a normal starting position, like after a homing would be. And when I have the selection over here, I can see that I have the coordinates on the bottom. When I go to the program editor, I can just select action and select joint motion. And what I can see over here is that all of the actual coordinates of the digital twin, and thus the actual robot, if it's connected, have been loaded successfully directly to the command. So I minimize it, and then I move to the second point, which it will be here. And I do the same. So action, joint motion. Again, all the coordinates are loaded. Then I will move the Z-axis down to simulate picking an item. And of course, because we have a gripper connected, what we can do is manipulate one of the digital outputs of the Igus robot control hardware. As standard, the Igus robot control cabinet comes with 7 inputs and 7 outputs, but we can configure it to have up to 21 inputs and 21 outputs. So if I select action and I press digital output, of course I can select gripper as well. I can select digital output 21 to be enabled, so I can grip the item that I want. Then I can move the Z-axis up, save the motion, and then move to the first point to the start. So instead of, again, moving the robot, I can just press the line, press Control and copy, so Control and C, select the bottom line, and paste the motion. So it's very easy to copy, paste, and delete motions. What I can do now is save the program now that we have finalized it, and of course I can also disable the gripper once I reach at the beginning. So I just select grip digital output and disable it. So let's save it, file, save as, and we can have it as test 00. So this is saved. We can close that, and we can load the actual program to the robot itself. So I'll select the program, press load, select the program, press open, and now the program is loaded. So if I press play, we're going to see the gantry performing the program that we have actually instructed. If we have a closer look on the bottom toolbar where we have the inputs outputs, we can have a closer look at the digital output 21, which should be acting as an on when we try to pick the robot. There it is, and then disable when we are again at the start. So everything is done, and this is mainly the programming, the basic programming of what the Igus robot control can do. Again, the main benefits for the Igus robot control is the ease of use, and as no programming experience is required to program the robot, as you've seen, it's very easy. It's the quick return on investment, having a very low-cost modular hardware as well as a free-of-charge software. And also for learning, we have learning videos online, and we also have a dedicated software support team, which is dedicated to the Igus robot control to help you with whatever you want to do with the Igus robot control, so you can have expert advice at any point. Hope you like the walkthrough. I'm going to hand back to Adam.
Brilliant, thank you, Angelos. And yeah, hopefully, that was, everybody was able to see there sort of how simple you can create a fairly complex sort of motion with the robot control. So yeah, the sort of the last thing from myself really is to say, please go to the Aegis website. Hopefully that's coming through now. You can see that the low cost automation tab is there. Is that coming through? Hopefully it is. Anyway, yeah. So click on the low cost automation tab, and you will see this section here, which is our low cost automation landing page. And here you will find everything and more about what we've talked about today and what we can offer. So apart from saying thank you to everybody that's here today and attended, the last thing is to sort of key point is imagine what you could do with robotics when they're low cost. because that's what we're trying to offer. So thank you, and hopefully, Paul, there's been a couple of questions maybe that we can answer.
Yes, yes, indeed, there have. Thank you very much, both Adam and Angelos, for that. That was fascinating. First question that we have is low cost has been mentioned throughout the webinar, but what exactly is the cost of an Igus robot? Okay.
Brilliant. Yeah, good question. Thank you for that, whoever asked it. So it's not a simple one to answer, to be honest. Obviously, we have the 3 different styles of robot which carry different prices. But let's pick on a gantry. Let's say, for example, that you would like a gantry system, a 2-axis gantry. If you would like that with the motors, you're typically talking around £2,000. If you would like that with stepper motor controllers, so just controllers to operate the 2 motors, then you'd be talking around 2,900, something like that. If you want the Igus robot control, then you're talking around 4,500. So depends on the level, and we like to offer the levels, because not everybody wants the Aegis robot control. Certain customers would like the gantry, be able to fit their own motors and carry on. So if there's any other specifics, if somebody out there listening right now has a specific sort of question regarding cost, please get in touch with me. My details are on the Igus website. Get in touch with me or Angelos directly, and we'll answer those straight away.
Thank you very much. Second question we have is, what is the delivery time of an Igus robot?
Okay, yeah, again, a good question, and one that we get asked quite a lot, really. And again, depends. We actually carry standard gantry systems in stock in Northampton with our stepper controllers, not the robot control, because they're more of a bespoke build. So if a customer needs a gantry and they can work with one of our standard systems, they can have it the next day. We can deliver that within 24 hours. But if it's more of a bespoke build, typically 4 weeks.
Thank you very much. And the final question we have is, if I had an application but needed to prove a concept or idea, is there a facility within Igus that could do a basic function test?
Okay, yeah, again, but brilliant question. Thank you, whoever asked that. So yes, essentially, what I showed you, one of the very earliest slides, where I mentioned Igus UK. We have a dedicated low-cost automation testing and development area. Within that area, we are doing exactly that. We're doing proof of concepts. We're doing testing for customers. So if there is something that you think, could Igus robot arm, pick up my widget and put my widget where I need my widget to be? Well, yeah, exactly. We can do that. We can come and visit you. We can, look at what you're trying to do. We can take away sample pieces to rig up or mimic what you're trying to do. And we can do that at Igus UK. You can come and see that once it's complete, or we can take some videos. We could have a virtual visit or whatever to show you, and hopefully, yeah, give you the confidence that the robot will do exactly what you need it to do. A really good question. Thank you, whoever asked that.
Okay, thank you very much. That's all the questions we have time for at the moment. As I said earlier, though, if there are any further questions that we've not been able to answer, we will be passing them on to Igus, and they will hopefully be able to get in touch with you and answer those. And all that remains for me to do now is to say thank you very much to Adam and Angelos for the presentation, and to thank our audience for attending. Thank you very much.
Thank you. Yeah. Thank you very much. Thank you very much.